Good afternoon to one and all. It's my pleasure to introduce S. Karthikeyan sir. He is a principal counselor of Indian Green Building Council CIA. Has about 18 years of rich experience in energy efficiency in industrial sectors like power plants, data centers, and buildings. The major responsibility includes policy and advocacy in energy area, consultancy of green performance, facilitation of implementation, green product in market development, and capacity building for enhancement benefits of green buildings. He is leading services for green buildings, Green Pro, and green efficiency services for several years now. Karthikeyan sir has been instrumental in developing many of the IGBC rating system, including IGBC Green Data Center rating system. I hope you all can remember the green building rating system. He is one of the major head behind those rating systems. Also, he has worked for national and international projects such as energy efficiency in Indian data center and development of standards for net zero energy building. We are extremely glad to have him as a speaker today for green building. I hope he will enlighten us about more about the green building, its efficiencies, the data, and how the green building is related to the rating. I welcome you, sir, and please hand over the mic to you.
Thank you, ma'am. Thank you very much. Very good afternoon, friends. It is always a pleasure to talk to the students. Especially, I wish I could physically meet with you all and make this presentation. We always look for this opportunity. Being with the industry for quite some time, it's always pleasure to interact with the young minds and then share our thoughts. And in fact, we learn a lot also when we interact with the students like you. So it's my pleasure and privilege to be part of this August group and then share our experience in terms of net zero energy buildings. So the idea is, I have a presentation. I will try to make the presentation within about some 45 minutes and then keep about some 15 to 30 minutes for the question and answer. Is that fine, ma'am?
Yes, sir. Yes, sir. Perfect.
Yes, sir.
I will do that way. 1 minute. Let me share my presentation. The entire screen. Yeah. I hope my presentation is visible to you all.
Yes, sir.
Yeah.
Yes, sir.
Thank you very much. Friends, I am from Confederation of Indian Industry, Indian Green Building Council. The Indian Green Building Council, this council mainly promotes green buildings and built environment in the country. We have been working on this close to about some 2 decades now. I started my career with this, in fact, in 2001, almost last 22 years I have been working on this. Before even start promoting the green building concepts, our chairman said, before start preaching, you have to practice yourself. So we built our own building, the Green Business Center at Hyderabad, as a green building. That is the first platinum rated green building. In fact, that is the first green building in the country as well as the platinum rated building in the country. And we were fortunate to get Dr. APJ Abdul Kalam to inaugurate the building. In fact, that is a very proud moment for all of us still. And then today, it has got more than about some 55 to 60 features. So my first request to you all is, if you get an opportunity to visit Hyderabad, please make it a point that you also visit the Green Business Center. It has become more of a tourist spot nowadays. And today, it has also become a net zero energy building. I will talk about the building as part of the presentation at a later stage. In fact, the building, the entire energy requirement for the whole year, we met through our own generation. And in fact, we export more power than our requirement to the grid. So it's a net zero energy building. And we are also aspiring to achieve net zero water, net zero waste, and ultimately net zero carbon from the building point of view. So this is how we have been working on. So as part of today's presentation, I'm going to only talk about the net zero energy concept here. What is net zero energy building? If you ask me what is net zero energy building, the definition goes like this. Net zero energy buildings are those that are designed to have the lowest energy demand. If the building energy demand point of view, if you look at, it should be the lowest. It should be a very energy efficient building during the operation and maintenance. And after meeting the energy efficiency, the entire energy requirement of the building should be met through the renewable energy sources. In this definition, you see two parts. One is the building has to be very energy efficient. That means the energy consumption of the building should be very low. And second, even the low energy consumption should be met through the renewable energy sources. Now the question arises, why the energy efficiency should be very high? Why not the entire energy consumption is met through only renewable energy sources? If I meet through renewable energy sources, is it not a net zero energy building? So imagine if you have an inefficient building and then you are trying to meet the energy requirement through renewable energy sources, what will happen? You will end up in putting more and more renewable energy sources for meeting the requirement. In fact, your investment only will go very high. So it is something like trying to fill a leaking bucket. If the bucket is leaking and there is no point in trying to keep on filling this. If you do so, ultimately the leakage only will increase. So fundamentally, if you look at in terms of a net zero energy building, first it has to be very energy efficient. Energy efficient in the sense it should be better than the baselines in the country. And then after meeting the energy, making it more energy efficient, it has to meet all the requirement through the renewable energy sources. This is a typical approach we adopt from a building point of view. When we talk about net zero energy building, there are two major aspects in a building component point of view. One is the passive element we talk about. I understand you are all mechanical engineers, so I try to make it more suitable for mechanical engineers here. The passive element in the sense it is all about the building structure. Okay, it is all about the building structure, the orientation of the building, the envelope of the building. When I say envelope, it is all about the walls, the roof, the glazing, all those things we need to consider. We have to make the envelope more and more efficient. Okay, so the first thing is the passive elements need to be made more efficient. Then we need to look at the active elements. When we talk about active elements, these are all the equipments that are functioning. For an example, air conditioner is an active element. Lighting is an active element. For example, a fan, if you have for exhaust, that is an active element. So these equipment need to be more efficient. So first I am making the building, the passive element more efficient. Then I am making the active element more efficient. And then after that, we are going for the renewable energy sources, both on-site as well as off-site. This is a typical approach in terms of achieving net zero energy status in the building. Having said this, typically, if you look at the building energy consumption point of view, this is how the energy consumption looks like. In an air conditioning building, the energy consumption on account of the air conditioner is the maximum. It accounts for close to about some 60%. Then comes in terms of the lighting, the miscellaneous equipment, or the ventilation fan. All those things are coming in. I'm not saying this is the breakup. This is one of the breakups of a typical building system. Having seen this, our major focus obviously would be towards the air conditioner, isn't it? Because that is a major energy guzzler. The energy guzzler we need to focus on in terms of how we can reduce the energy consumption there. Then, having got air conditioner as a major energy consumer, how the air conditioner gets loaded, if you look at it, is on account of the heat gain in the building, isn't it? What is the purpose of an air conditioner? The air conditioner has to remove the heat and throw it to the atmosphere. If he has to remove the heat, that means somewhere the heat gain is happening in the building. Where the heat gain is happening, the heat gain is obviously coming from the sun and the atmosphere. The sun, solar radiation is the direct source of heat gain. And also when the atmosphere is hot, obviously again it is coming from solar radiation only. When the atmosphere is hot, then again the heat gain is happening from the atmosphere. So this heat gain need to be removed from the building so that the building is maintained at a particular desired temperature and the humidity. isn't it? So what are the major sources of heat gain if you look at? Fundamentally in building, especially in the modern building, the heat gain is on account of the glazing. Probably in the ancient building, if you look at, we don't use that much of glass. It is only on account of the walls and the roof. Okay, so presently in the modern buildings, the major heat gain is happening on account of glass. So we need to be very, very careful with the selection of the glasses. There are various properties that need to be looked at. We will talk about that. There are various properties that need to be looked at, and then we have to make the glazing more efficient. Then we have to look at the wall, we have to look at the roof, and we have to see how we can make these components more efficient so that the heat gain in the building can be reduced. So the typical approach, if you look at, it starts from the design of the building. The design of the building, even the orientation matters a lot in terms of reducing the heat gain in the building. I will talk about the orientation. It starts with the orientation of the building. Then the envelope measures. When we are talking about the envelope measures, as I said, it's all about wall, glazing, the fenestration, etc. Then comes the equipment and system. When I say equipment and system, it is the mechanical equipments, the air conditioners, lighting systems, the pumps, motors, all those things we need to look at. Then we have to focus on the controls. Okay, you see a step-by-step approach. Then we have to focus on the control, and finally we have to look at the commissioning. It is the last aspect, but it's a very important aspect in terms of the commissioning. So starting from the orientation of the building, addressing the envelope measures, addressing the equipment and systems, then going for an improved control, and then efficient commissioning process improves the overall energy efficiency of the building. I will just try to explain the orientation process here. This is a typical building. This is a typical building which is facing east-west, and this is the north direction. We all know the sun rises in the east and sets in the west, isn't it? But if you look at especially a tropical country, the sun travels most of the time. It travels towards south, and then sets in the west. So if you look at a building, the major heat gain is especially happening in the west direction as well as the southern direction. Especially in the south, the heat gain will be much higher. So obviously what we will try to do, we will try to make the southern part more efficient in terms of reducing the heat gain. We will look at in terms of how we can reduce the glazing in the southern part, how we can increase especially the shading devices. Even if it is required, we can look at increasing the insulation or any shading that can be used so that you can reduce the heat gain in the southern part. So especially in the south as well as the west, we look at various options in terms of reducing the heat gain. Ideally speaking, we should be able to rotate the building so that in southern part the area exposed is lower, but it doesn't happen always because the plot size, in majority of the cases, the plot size and orientation decides the building orientation as well. So we need to look at all these aspects and then work on in terms of reducing the heat gain. In fact, when we work on this, we come out with a simulation, and that simulation we impose on the sun path diagram and then work on how we can rotate the building so that the heat gain of the building can be minimized. Typically, if you look at the orientation aspects, can reduce the energy consumption by about 2 to 3%. You may say, what is this 2 to 3%? 2 to 3% is very small if you look at in terms of energy consumption. But please keep it in mind, if you do this once, for the entire life of the building, you are going to reduce the energy consumption by 2 to 3%. So if you look at the overall life cycle of the building, the energy consumption you are going to achieve, or the energy consumption reduction you are going to achieve, would be very, very significant, though it is only about 2 to 3%. So this is about the orientation aspect. The second aspect is related to the envelope measures. The envelope measures, if you look at, as I said, nowadays with the modern building, the glazing is a major component that also allows more amount of heat to come inside the building, isn't it? So how much is the glazing we can go for? The glazing, there are certain benefits of glazing as well, because the glazing, it gives a fantastic architectural view. There is a good connectivity given because of the glass, because when you sit inside you will be able to see outside. There is an external connectivity. Above all, you get a very good daylighting also, isn't it? Your lighting energy consumption significantly comes down. But at the same time, the glass also allows the heat to come in. So if the heat comes in, what will happen? The load on the air conditioner will go up. If the load on the air conditioner goes up, your energy consumption on account of air conditioning will go up. So there is a need for balancing the glazing in terms of daylight as well as the air conditioning requirement. There are certain parameters we look at in terms of how we can optimize this. For an example, the U value of the glass, or the shading coefficient, or solar heat gain coefficient, and the visual light transmittance. These are some properties you need to know. As a mechanical engineer, you will not have studied this in your curriculum, but when you are working on buildings, especially designing the air conditioning system, you need to be aware of these aspects for estimating the heat load in the building. Because as a mechanical engineer, you will be getting into the design of air conditioning system. The design of the air conditioning system, the first step is you need to know what is the heat load in the building, isn't it? If you need to know the heat load in the building, you should know all these aspects so that you can estimate what is the heat load that is coming into the building. So there are basically looking at these three aspects: the U value, the shading coefficient or solar heat gain coefficient, and the visual light transmittance. So if you look at it from the heat transfer point of view, of course, we all know there are three modes of heat transfer, isn't it? We have been studying this from the school days. There is something called convection heat transfer, something called conduction heat transfer. Of course, starts with conduction, convection, and radiation. If you take a building, the building gains heat on account of all the three modes. All three modes of heat transfer is happening. See, for an example, if you take a window, there is a direct heat gain coming in because of the radiation. From the sun solar radiation, there is a direct heat gain coming in. It falls on the glass. Some amount of heat will directly get into the building. Some amount of heat will also get reflected, isn't it? Radiation, that is what is happening. If you have two products, both the products will exchange heat because of the radiation. So some amount of heat will get reflected also. And again, some amount of heat will get absorbed, get transmitted. Again, it will get transmitted both inward as well as outward, depending upon the temperature difference. So similarly, when the outer atmosphere, if you look at, it can be anywhere, especially in India, if you look at, the temperature varies anywhere between, say, 30 degrees centigrade to as high as about, for an example, if you go to Korba or Rajasthan, you will have even 48 degrees centigrade. Okay, sometimes it touches 50 also. 48, 50 is quite normal in those areas. So because of the temperature difference, but you want 24 degree plus or minus 1 to be maintained within the building. So this temperature difference that leads to both convection as well as conductive heat transfer. So the point is, through all modes of heat, the building is gaining the heat, and that heat to be removed by the air conditioner. Now, having seen this, the U value, it plays a significant role. I will just give you only one example. A single glass, a 6 mm plain glass, if you take 6 mm plain glass, majority of the time in houses and all, we use only the plain glass. The plain glass U value is about 6 watts per meter square degree Kelvin. That means, when I say 6 watts per meter square degree Kelvin, if you take 1 meter square area of single glass, if the temperature difference is 1 degree, it will allow 6 watts of energy to pass through. Okay, that is the meaning. When I say 6 watts per meter square degree Kelvin. There are high performance glasses available. When I say high performance glasses, these are all like a double glasses and triple glazing. Double glazing is nothing but you will have two glass. In between the glass, you create a vacuum, and then you fill it with argon. Argon is basically an inert gas. The heat transfer coefficient of argon is much lower. So obviously, the heat transfer through the glass will be much lower. So if you take a single glass, it allows 6 watts of energy to pass through. In case of a double glazing, it allows only about 2 watts of energy to pass through. That means 1/3 of energy is not, or the heat is not passing through the glass. That means your heat load in the building is coming down, isn't it? So these kind of high performance glasses are extensively used in modern buildings. And also the shading coefficient, it plays a significant role here. For an example, if you take single glass, there is something called solar heat gain coefficient we talk about. The solar heat gain coefficient is, you have a single glass, keep it under the sun, the entire heat that falls on the glass will be passed on, isn't it? You will feel the entire heat below also. So it is not exactly the entire heat, it will pass on more than about 90% of the heat. So that means the solar heat gain coefficient of the single glazing is 90%. If you take this double glazing, it will not allow the entire heat to pass through. It is very similar to having a sun film. We all know the sun film, isn't it? You put a black color film on the glass so that you are able to reduce the solar radiation directly. In the glass, you don't put the film, but the vacuum and the performance of the glass has been improved so much, it will allow only some 40% of the heat to come through. So that means remaining 60% of the heat will get reflected back, isn't it? So it doesn't allow the heat to go into the building. So these kind of measures reduce the heat gain in the building. I'll just skip this. Very similarly, walls and roofs, these also need to be made more efficient. There are multiple technologies available to make the building walls and roofs to become more efficient. And the U values of these matter more. For an example, RCC walls. Nowadays, we talk about in terms of thermoconcrete RCC walls. Thermoconcrete means it has got a foam concrete. That means there is an aeration done, and because of that, there is some air gap, and you don't compromise on the strength. But because of the foam concrete, the thermal insulation property is much better. And because of that, you are able to reduce the heat gain through wall and roof. See, for an example, if it is a very high-rise building in the sense about, say, 40 floors, 50 floors, in those buildings, the heat gain on account of the wall is very, very high compared to the roof. So, a lot more importance has been given for improving the wall performance. So we work on in terms of how we can improve the insulation, how we can improve the thermal property of the wall, so that the heat gain on account of the wall can be minimized. On the other hand, if it is a flat building, say about only 2-floor building or 3-floor building, in those buildings, the heat gain on account of the roof will be very high compared to the wall. So we give a lot of importance for the roof to become more efficient so that the heat gain on account of the roof is coming down and overall performance is improved. There are multiple wall options available, the brick wall, the insulation, the air cavities, all those things we bring in. Even nowadays, the AAC blocks, it improves the performance significantly. And because of that, you will be able to improve the energy consumption significantly, at least about 3 to 8%, you can do that. So these are some examples. For an example, the insulation materials that are available, like glass wool or thermocol or extruded polystyrene, polyurethane, these materials we use as part of the wall for improving the insulation of the wall so that the heat gain can be brought down. See, being a mechanical engineer, you should be aware of all this because ultimate objective for you is to reduce the energy consumption in the building. If you have to reduce the energy consumption in the building, the major component is on account of the air conditioner, as I said, and then the lighting. So if you have to reduce the energy consumption in the air conditioner, all these properties you should also be aware. You might not have studied so far in the curriculum, it may not be there, but all these need to be understood over a period of time so that you can work on this. Enormous opportunities are there. For an example, roof insulation. We work on this roof insulation so that the heat gain in the roof can be reduced. Typically about some 3 to 8% reduction in heat gain can be achieved in this. So the insulation, we can think about sandwiching between the top layer and the roof so that your insulation is very well protected. At the same time, the heat gain is reduced. Similarly, in case of wall insulation, see, on top of the wall, you put the insulation, and then over that, you will have another layer or the cladding, so that your energy, the heat gain in wall also can be minimized. There are different brick technologies available. For an example, AAC blocks, the latest trend, they reduce the heat gain significantly in the wall. So these kind of bricks also we recommend for use in the buildings for reducing the heat gain. Because if you look at the AAC block, the U value is much lower compared to the red brick. Red brick, if you take the U value is nothing but it's a kind of as I explained earlier, in terms of watts per meter square degree Kelvin. Okay, so how much is the energy it allows to pass through? In case of red brick, it is anywhere between 2 to 2.5 watts per meter square degree Kelvin. But this AAC block has got only about say 0.7 watts per meter square degree Kelvin. So obviously the heat gain will be much lower here. So there are multiple options in terms of addressing the envelope measures. By addressing the envelope measures alone, you would be able to reduce the energy consumption at least by about 10 to 15% straight away. There are multiple options you need to work on, and then you have to improve it. And these 10 to 15%, please remember, this is for lifelong. Once you implement in the building, you are going to get it for the entire life of the building. If the life of the building is about 100 years, the entire 100 years you are going to gain. Generally, we consider about 50 to 60 years in practical terms. But typically the old buildings, you can see even if it is available for 80 to 90 years. Then comes the equipment and system. So first you have addressed the orientation. The second, you have addressed the envelope measures. And third, you are going to select the equipment and system. Selection of equipment is the key from the point of view of improving the energy efficiency. As a mechanical engineers, you guys have studied about the air conditioning systems. You know what is COP. COP, how much should be? I don't want to get into what is COP and how this has been measured, etc. But there are standards available. For an example, ASHRAE 90.1, it specifies what is the minimum COP you should consider. But there are systems available in the market which are much better than the ASHRAE 90.1. In India, we look at Bureau of Energy Efficiency Standards. Bureau of Energy Efficiency specifies what is the minimum COP that need to be maintained. So in COP also, we look at integrated part load value, IPLV values. This IPLV value is much more important compared to the COP, the full load COP. Because majority of the time, the air conditioners will be operating at part load only. Part load in the sense, it will be operating at about say 65 to 70% of the load, full load capacity, majority of the time. Why this is? Because we add a lot of cushions while selecting the equipment, isn't it? If you estimate the overall load is about say 350 TR, I don't select a machine which is about only 350 TR. I land up in about 500 TR machine. So obviously, when I have a higher capacity machine and the load is lower, your equipment will be operating at part load. So obviously, I want the machine to operate at the maximum efficiency during the part load. So the IPLV value also is very important. If you look at the life cycle cost of the air conditioning system, typically it is like this. The initial investment is only about some 10%. And the maintenance for about 15 years, life of the air conditioner is anywhere between 15 to 18 years, a typical chiller if you take. So initial investment is about 10%. The maintenance cost is about 1%. The operating cost, if you look at, is about close to 90%. So why we are saying this is, lot more energy is consumed in the entire life cycle of the air conditioner's operation, and the operating cost is much higher. Even if you, but any efficient air conditioner, it will be slightly costlier. Even in household appliances, we would assume, isn't it? Compared to a 3-star air conditioner, a 5-star air conditioner is costlier. But if you look at initial investment and then buy a 3-star conditioner, you will land up in paying more throughout the life cycle. The same concept is applicable in large system also. So when you have a higher COP, the chiller is bound to be more efficient, more costly. In that case, people hesitate, and then they land up in low efficient equipment. So we insist on don't worry about the initial cost. Even if the initial cost is marginally higher, look at a more efficient equipment and buy it, because in the overall life cycle, your operating cost is very, very significant. So you'll be able to reduce the overall cost if you look at the life cycle costing. That is always our recommendation. So at the design stage, if you look at in terms of green building, air conditioning system, there are different mechanisms available. For example, conventional system, a chiller, you look at this. There are many passive systems we work on. For example, wind tower. I will talk about wind tower also a little on this. The geothermal cooling, external cooling, these kind of systems we have been working on. A conventional system, if you look at, you all might have seen this diagram, a chiller, how does it operate and how we work on this, etc. I will straight away get into the selection process. This is what I have been talking about. This is an ASHRAE standard. The ASHRAE standard talks about what is the full load EER, energy efficiency ratio. See, the performance of the chiller can be depicted in three ways: COP, energy efficiency ratio, or kilowatt per ton. These are all industry practices. All these are all convertible. You can convert EER into COP. You can convert kilowatt per ton into COP, or COP into all this. Okay. So generally, mechanical engineers at the during in our curriculum, we only talk about the COP. Okay. So the ASHRAE 90.1, it gives the values in terms of what is the full load COP and also what is the integrated part load value, IPLV values. So we need to look at both and then select a chiller. Suppose if I have to select let us say 150 ton air cooled chiller. The 150 ton air cooled chiller, what I am selecting, you should have COP of more than 9.5, EER of more than 9.5 and IPLV of 12.7. Then only I would be able to improve the energy efficiency of the overall building. So this gives us some kind of guidance. Similarly, there are different systems. The specifications are available. You can look at this. This is a typical air conditioning system. If you take a building or industrial building, you will find this. You will have a chiller. And then you will have a chill water pump which is supplying the chill water to the air conditioner, and then the chill water will be taken to the air handling unit. In the air handling unit, you will have air handling fans, AHUs. So in large systems, you will have two fans, supply fan as well as the return fan, and then that will be supplying to the end user area, and then the air will be circulating. There are multiple measures that can be implemented for improving energy efficiency. One is you need to address the end user level. This is where we work on more, especially the end user in terms of optimizing the temperature, humidity, working on the air handling units with the variable frequency drives, working on various pumps in terms of improving the pump, optimizing the pump, and also optimizing the chill water flow. These are certain areas we work on. Even for an example, we work on in terms of enthalpy control. For an example, in some time, especially during winter season, probably in say the middle part of the India, say Nagpur or Delhi, during winter season, the outside air temperature would be even more favorable. So what we do is we go for enthalpy control. The enthalpy, that means the enthalpy of the air, outside air will be also be measured. The enthalpy of air in the room, air handling unit also will be measured. If the enthalpy of air outside is better, that means lower, you allow more fresh air to come in. So that the air conditioning load is reduced. Okay. Similarly, we work on variable frequency drives for the pumps, the chillers. There are multiple measures that are possible in terms of improving the overall energy consumption of the air conditioning system. This itself is a major process in terms of doing the energy audit, looking at the performance of each system, and then how you can improve upon. See, for example, generally in case of chiller, you will have a cooling tower also. The cooling tower, you have water-cooled cooling tower or the air-cooled cooling tower. How the cooling tower performance is very critical in terms of improving the performance of the chiller, isn't it? Because if the condenser temperature increases, the performance will come down. So you need to maintain the condenser temperature as minimal as possible. As minimal as possible in the sense that there is a limitation, isn't it? If you have a water-cooled chiller, the minimum temperature you can achieve is the wet bulb temperature of the air, isn't it? So obviously, to that extent, your approach should be as minimal as possible so that your overall performance of the chiller is the maximum. There are many passive measures we work on in terms of wind towers. For example, natural air pathways are being looked at. These require absolutely no energy. There can be a very small fan which circulates the air to pass through. And these wind towers will be long towers like this. You can come to our office and then see the wind towers functioning physically. These wind towers will have thermal mass inside. And thermal mass, you spray water on the thermal mass and then allow the air to flow through. Then obviously, because of the airflow, water will evaporate. There is an adiabatic cooling happening. Water will evaporate and then the temperature of the air will get reduced. And the cold air is given as an input to your air handling unit. So when the cold air is given as an input to the air handling unit, your air conditioning load also comes down, isn't it? So when we are starting, let us say our office starts from 9 o'clock onwards. So we start this wind tower by about 7 o'clock. In the morning, 7 o'clock, you start with a small fan, spray water. The entire building gets cooled first with adiabatic cooling, very low energy consumption. And then you, at about 8:30, 8:45, you start the air conditioner. Your energy consumption is already, the building is already cool. So your heat load on the air conditioner is much lower. So the energy consumption will come down, obviously. Okay, so this kind of integrations are possible. The passive and active cooling integrations are possible for reducing the energy consumption in the building. Similarly, the geothermal system. Geothermal system we have been using in many of the buildings. See, for example, the idea is below the earth, at least about a 4-meter level below the earth. The temperature is by and large uniform. The average temperature of that particular location has been maintained. That means during summer, the temperature below the earth at 4-meter level will be lower. During winter, the lower compared to the atmosphere. During winter, on the other hand, the temperature will be higher compared to the atmosphere. So how to make use of this? What you do, you put fume pipes in the below the earth at 4-meter level and then circulate the air through the fume pipes. The fume pipes will act as a heat exchanger. So during summer, the air gets cooled because of the lower temperature and then the cool air is supplied to the building. On the other hand, during winter, what you do, you supply the same air, it gets heated up or it becomes warm and then the warm air has been supplied to the building. So you are able to maintain the desired temperature in the building. So this kind of external cooling also is possible. So these are various mechanisms by which you reduce the energy consumption. And finally, the lighting also you look at, isn't it? The lighting is a major energy consumer. There are systems available. The lighting, it has developed over a period of time from age-old GLS lamp. When I say GLS lamp, that was invented by Edison, isn't it? That bulb is no more valid now. The tungsten filament lamp. Okay, that is the most inefficient lamp, to be very frank. On the other hand, it gives a very good color rendering index. You can see the true color of it, isn't it? You put a silk saree beneath the GLS lamp, you will see the true color. On the other hand, if you go for some other lamp, the color rendering index is poor. So there are some advantages and disadvantages, but it is supposed to be the most inefficient. But over a period of time, the lamps have improved a lot. From there, we started looking at the fluorescent lamps. Then we started looking at the compact fluorescent lamp. The latest is obviously the LED, light emitting diodes. The light emitting diodes, when I started the career, at the time the light emitting diodes were used only for some, indication lamps. Now LED has been used even for floodlight, isn't it? A large cricket stadium, it is lit with LED lamps. So the LED lamps, they consume much lower energy consumption. So we look at in terms of the lighting power density in the sense how much is the watts energy consumption per square feet of the building. The typical standard is about 1 watts per square feet. Nowadays, because of the advanced technology, the energy consumption has come down to the extent of even about 0.3 watts per square feet. And a lot of controls have been used. For example, movement-based controls we look at, and image-based controls we look at, automatic controls we can look at. So there are multiple controls available. Depending upon the locations, we use those controls and then go for improvement in energy efficiency. Similarly, the controls and BMS, as I said, the BMS is building management system. The building management system is a very, very effective tool. There are a lot of remote controlling is possible. And nowadays, it has become more of a cloud-based controls. I can sit at Delhi and then see what is the energy consumption in my building in Hyderabad. So everything is nowadays available. The data is very closely monitored, measured, and then it has been put on cloud. I can see what is the power consumption of the pump in Hyderabad, and even I can switch on and switch off. All those aspects are possible with the support of these cloud-based controls. What is the advantage? Advantage is I can very closely monitor what is the energy consumption in the building. Where is something going wrong? Is the pump performing well? Okay, I can predict what is the performance of this pump or the air conditioner. If something is going wrong, then I can immediately take the preventive measures. I need not to allow it to break down and then work on in terms of corrective measures. Okay, so those kind of aspects are possible. And second, I can also do an analysis of all these energy consumption figures and then look at where I can optimize. Oh, there is a system available which is unnecessarily running, and how I can optimize this. Those kind of decisions can be taken based on this building management system. These building management systems give significant reduction in energy consumption because you are able to very clearly control. The last but not least is the commissioning process. Commissioning is something like, you have to evaluate the performance of all these equipment and then see, is there a deviation from the design? Because any deviation from the design will lead to inefficiency. So a third party, an expert in energy efficiency, he will study the performance of the equipment and tell you, okay, this is the design parameters. You have looked at all the design parameters, whereas the equipment is operating in a different mode. It is not operating as per the design. Why is it not operating as per the design? What are the corrective measures that need to be taken up? All these we will look at in terms of commissioning. It's a kind of third party review. You do the examination. You after writing your examination, it goes to somebody else and they correct the paper and then let you know, yeah, this is the mark you have achieved, isn't it? That gives by and large an accurate estimate of the performance of the student. Very similarly, this commissioning has been done by a third party so that they can improve the performance of the equipment. Why I have talked about all these is, when we talk about net zero energy buildings, the net zero energy buildings, as I said, it has got two components. One is the energy efficiency, then second is the renewable energy. Without addressing the energy efficiency, you cannot switch on to the renewable energy at all. So for improving energy efficiency, all these 5 steps need to be adopted and then improve the performance of the building. Having improved the performance of the building, then you start working on the renewable energy. The renewable energy, you can put on both the on-site as well as off-site to meet the net zero requirement. So having reduced the energy consumption to the bare minimum requirement, then you go for renewable energy options. I can look at, say, the solar PV systems, or I can look at even small wind turbines, or I can look at fuel cells, multiple options we can look at, and then in terms of meeting the requirement. Even in this renewable energy, our approach is like this. First, you have to exploit the on-site. Why exploiting on-site? If you go off-site, there will be a transmission and distribution loss, isn't it? You put the power plant somewhere else, the solar PV somewhere else, and bring the power here, there will be a distribution loss. So first, you put it within the site as much as possible, and then obviously every site cannot meet all the requirement. So you need to put something outside. And after meeting the requirement here, then you go for offsite requirement. So through this, you will be able to achieve the entire energy requirement met through the renewable energy sources. Now, I want to talk about few case studies. Okay, is it really possible? Yeah, this has been implemented in many projects. Our own case study in Hyderabad, this is the building I am talking about. We have gone for many energy efficiency measures and then gone for the bifacial solar PV modules. This is something very unique. You all might have seen solar PVs. It will generate energy on only one side. This solar PV module, it can generate energy on both the sides. This is called bifacial solar PV. What is the advantage? I can increase the power generation with a given area, because the area is always a limitation with respect to building. So I can maximize my power generation in that area. It will give you at least about a 3 to 4% increase in efficiency. On account of that, there will be 20% improvement in terms of the power generation as well. This is the way we have met the entire energy requirement in the building. In fact, we are exporting more energy to the grid so that we are able to achieve net zero energy. Not only our own buildings. See, for an example, Godrej & Boys in Mumbai, this is more of a convention center. It has got a meeting room, it has got a large hall, it has got a restaurant, it has got some office building. And they have gone for all these energy efficiency measures and then put extensive renewable energy sources. They have gone for on-site 120 kilowatt peak and off-site of 1.2 megawatt renewable energy. They have gone for it, and they made this building completely net zero. This is a warehouse, Gopikan Terminal in Mumbai. This is a warehouse which has adopted a similar approach in terms of going for solar PVs and then achieving the entire energy requirement of the warehouse through renewable energy, and then made themselves net zero building. This is a Capgemini. It's a IT park in Bangalore. IT park is very energy intensive. It's a 24/7 operation, isn't it? The energy requirement is much higher. So they have gone for about close to 14 megawatt hour per year of energy through renewable sources, and then they made themselves as net zero. In fact, they wanted to maximize the installation of renewable energy within the site. There was a swimming pool. The swimming pool area, the side area, even there also they have gone for solar PV. So that is the reason I have taken this photograph and put it here. The entire roof has been covered with the solar PVs. This is a training center in Jodhpur, ICICI Bank training center. They have also had gone for extensive amount of renewable energy. A lot of education institutions, they are going for net zero energy because the space availability is a boon for them. They have a lot of space to put renewable energy sources, so they are able to achieve the net zero energy consumption. This is a house. When I say it is a house, it is also a bungalow, to be very frank. This bungalow is located in Chennai, and they have gone for ECBC 2017 for meeting the energy efficiency requirement and then renewable energy to make their building net zero. See, the point what I am trying to highlight is, it doesn't matter what type of buildings or built environment you have. Every building and built environment can aspire to achieve net zero energy. Because this is a concept. This concept can be applied on anything. For an example, in case of Gujarat, the Pollution Control Board head office is the net zero energy building. Pollution Control Board head office in Ahmedabad is a net zero energy building. So in Delhi, the Ministry of New and Renewable Energy Sources, MNRE building, that is also a net zero energy building. So any building can aspire to achieve net zero energy building, and it gains importance because number one, it makes a lot of business sense. Gone are those days where the renewable power generation cost is much higher compared to the grid power cost. Today, the renewable power cost is much lower compared to my grid power cost. In the sense, if I buy power from the electricity board charges me about, say in case of commercial tariff, it is as high as about 8 to 10 rupees per unit. I get the renewable energy at about 3 rupees per unit. Is it not business sense for me? So it makes a lot of business sense, or it is profitable for me to go for more and more renewable energy and then reduce my energy cost. There are many challenges at this point in time. I don't want to discuss with you these challenges. These challenges are more related to the policies and regulations. We have been working with the government. We have been working with the distribution companies in terms of addressing those policies and regulations, and then make these policies favorable for the net zero initiative. Friends, these are the points I just thought of highlighting, highlight to you with respect to the opportunities related to buildings and building sector in terms of net zero energy. The opportunity is enormous. In India, the building sector is growing. Building sector is growing in a way. More than about 70% of the building that would be available in 2040, 2050 are yet to be built. That means we are going to triple our building footprint in the next 20 to 30 years. If we are going to triple our building footprint, that means the opportunity is very, very significant. So when we are going to triple, we have to triple it in a very sustainable way. So the net zero concept helps us in addressing this in a very, very sustainable way. Okay, so this creates enormous opportunities for students like you. You can pursue your career in net zero energy. And I just thought of highlighting one small initiative taken by CII with respect to green education. This is something we have been working with the AICTE and then promoting this green education amongst all the students community as well as the education institution. Our vision is to enable India to have the largest pool of trained professionals, because when we are going to triple our footprint, when the growth is very high, we want more and more trained professionals. If you don't have trained people, it is impossible to grow at that level. You people may be aware of fundamentals, but I am pretty sure even when I passed out of my college, I was not ready to meet the industry requirement. There is a need for a lot of training to meet the industry requirement. So for this, what we are trying to do is we are training the students to meet the industry requirements on green concepts, the site visits, a lot of training programs and concepts are being taught, the workshops are being conducted, so that you are ready, and you are also accredited as IGBC AP Associate. You might have seen this IGBC AP Associate. If you have this certificate, the industry recognizes this and the placement becomes much easier. The book is available. The course is about 45 hours of certification course on various aspects of green and net zero, etc. So this opportunity is available. There are benefits from the institution point of view as well as from the faculty point of view. There are multiple training programs that are conducted. So I would request you to make use of this. You can directly enroll and make use of this. So friends, this is how I would like to sum up. The opportunities, if you look at from energy efficiency point of view, renewable energy point of view, and also from the building sector point of view, even for mechanical engineers like you, not only mechanical engineers, whether civil or mechanical or electrical engineers, the building sector opens up enormous opportunity. I would say the net zero, it really makes business sense. Okay. So with this, I would like to conclude my presentation. If you have any questions or clarifications, I would be happy to answer. Thank you. Thank you very much.
Yeah, thank you. Thank you very much, sir. I request participants, if you have any questions regarding the session, you can directly ask. There is one question from Professor R.B. Varia, sir. So he asked that to select orientation of house according to the sun movement, which month is ideal?
Okay, sir, the orientation, we don't do it for a month. Okay, what we need to do is when we are simulating whether it is a house or a large building, we first do the simulation and we work on the sun path diagram for the whole year. Okay, for the whole year, the sun path diagram has been simulated, so that which direction of the house, if you rotate, okay, or a building, if you rotate, a particular direction which gives you the lowest heat load, that direction is chosen. Okay, so it is not about a month or a day. It is for the whole year you need to simulate.
Thank you, sir. Any more questions?
Hello.
Yeah, please, sir.
Sir, you say in your first slide, the efficiency of HVAC or air conditioning is 60%, and other conditions of
I
lighting
did not say
and
efficiency, sir. I did not say efficiency.
it is load.
Energy consumption.
Energy consumption. So is
The
this
percentage
for
of energy consumption.
yes, sir. So is it for an ideal condition or any for special conditions?
It's a typical condition, sir. It's a typically. It will vary. For an example, if you take IT building, which is completely air conditioned, it may have air conditioning energy consumption even at about 70%.
Okay, sir.
Okay. On the other hand, if you go to any office building, which has got about say 50% air conditioned and the remaining 50% non-air conditioned, okay, in those kind of offices, it will be only about 40 to 50%.
I think it is very suitable for the office buildings, sir, I think.
Yeah. So depending upon the building typology, this percentage will vary. But the point is, any building if you take, air conditioner will have the highest percentage.
Yes. Thank you very much, sir.
Thank you.
Yes, any more questions from any participant? The session is now open. So regarding that, the new buildings, if we see that most of the buildings have the glass facades now, right? So is there any government law to minimize that? Because like everybody is constructing, but nobody is taking care of the what kind of glass should be used, or its effects on the overall heating, or the radiation coming into the rooms and the building.
Yeah, see, actually, there are regulations available, okay, but they don't regulate on a particular equipment or a system. On the other hand, what they do, they regulate the overall energy consumption. So the Bureau of Energy Efficiency, they have something called Energy Conservation Building Code, ECBC. And this ECBC has been developed in 2007, and now this has been revised 2017. This thing is also available. And many of the states, they made it mandatory. For an example, in Hyderabad, if you take ECBC code need to be necessarily met. So when a building is constructed, they have to meet the norms of ECBC. Okay, there is an auditor who will look at it, and then they have to verify, and then they have to meet the ECBC requirement. If you are meeting the ECBC requirement by design, you are reducing the energy consumption. So, but this regulation is not there throughout the country. Some states have made it mandatory, and some states have kept it still voluntary measure.
Yes, sir, because that is what my observation is, that whatever new building I see, they front, back, east, west, north, south, they all are covered. covered.
Let me tell you, sir, many of the corporates, they are very conscious of building. They go for 100% waste building, but there are specifications which are much better compared to even wall, I can say. Yes. Okay, at par with the wall, I can select a glass. Okay, so that I can reduce my heat gain.
Yes, Arjun Panthi, you have any question? Sir, we're not able to hear you. I think that there is some issue with his mic. Okay, so any more questions? If there are no further questions, then we will conclude the session. So on behalf of everyone, sir, I would like to thank you, sir. Your session was very refreshing, very informative, and mentally very stimulating. We came to know across so many norms, so many small changes that can be done to maximize, the output. And on behalf of the BNBs of Technology, the organizing team of this training program, and the participants, I extend my heartfelt gratitude to you, sir, for taking time out for us and accepting our invitation and obliging, sir. Your
It's my
presentation,
pleasure,
sir.
sir.
Yes, the presentation was very, very, very informative, and I'm sure that participants would have gained a lot.
Sure, sir. It was very nice interacting with you all. Thank you very much for the opportunity. I will be
Thank
happy
you.
to work with you on this. Thank you.
Thanks a lot, sir. Thank you very much, sir.
Thank you.